seconds and counting. We're joined now by Kent Kellogg, who is with us here in the Mission Control Room. Kent Kellogg is our SMAP project manager with the Jet Propulsion Laboratory in Pasadena. And Kent has been working this program for about how long now, Kent?
6.5 years.
6.5. So this is the pinnacle of 6.5 years of work, probably for you and several members of your team, I would expect.
A bunch of us. A lot of us have been on it since early formulation, and then we have a number of scientists who've actually been working on this concept for 15 to 20 years. So
really?
It's a real treat for them.
Well, we're going to look now at some video of what went on both at Jet Propulsion Laboratory and then here at Vandenberg to get SMAP ready to fly. So, Ken, if you could tell us what we're seeing as we roll the video and go through the whole processing flow here, Ken.
Be happy to. So this is a test of our solar array. This was taken about a little over a year ago in the Jet Propulsion Laboratory clean room. Now we're looking at the radar assembly. This is part of the instrument that's on the non-spinning side of the spacecraft being integrated to the bus. This is the first spin test we did of the Goddard-provided radiometer and spin assembly being tested in the anechoic chamber. Now it's being lifted and installed on top of the spacecraft. This is our large deployable reflector boom antenna being tested. We've done a number of deployments, a total of 18. So this is a very well tested system. Now we're looking at the big reflector boom antenna being installed on the spacecraft. We put the spacecraft in an anechoic chamber to test it, to make sure that the electrical systems don't generate noise that could interfere with the science measurement. And then we test the spacecraft environmentally to make sure that it's compatible with the loading and vibration that we see on the spacecraft or on the rocket, and then the thermal environment and vacuum environment of space. And then finally, last July, we do an integrated spin test where we have the whole observatory together, and then in October 15, we ship the spacecraft to Vandenberg for payload processing. You see it now being loaded into the Astrotech payload processing facility. We shipped the spacecraft on an air ride van, so it got a nice smooth ride to Vandenberg. First thing we do when it arrives at Astrotech is to check out the systems and make sure that it's healthy after shipment. That all went very well. We had no issues following shipment. Spacecraft checked out perfectly. You can see it here being raised on its transportation fixture, kind of a great view of the whole observatory being raised from a horizontal to a vertical position prior to all the functional checkouts that we do. We load propellant onto the observatory. We have a little over 81 kilograms of propellant, and then we transfer the observatory from its fixture. Now you see the spacecraft. This is a really dramatic view that I like of the observatory being lifted and moved into the main clean room at Astrotech. So this is kind of a nice slow reveal showing the spacecraft in all its fully thermal blanketed glory being brought in. You can see they move the spacecraft very carefully, take a lot of care at this point. We've got a complex system that's been very well tested. You can see the propellant tank kind of sticking out a little bit below the bottom of the spacecraft, and it's being put onto its test stand following delivery. So once we get it in place, as I mentioned, we do the functional checkouts. Everything checked out good. We load propellant. Now we're moving the observatory to install onto the launch vehicle adapter. This is the piece of equipment that attaches our observatory to the top of the Delta II rocket. So this is one of the last steps that we take before we install onto the Delta II. This was done in early January, around January 8th. Now we're ready to move the observatory out to Space Launch Complex 2, where the Delta II is located. We first put a protective bag around the observatory. You see them doing those operations now. The next step is to install the observatory in a special can. So here you see them canning the observatory. Again, this provides an additional protection for the observatory as we transport it outside the payload processing facility out to Space Launch Complex 2, or SLC 2 as we call it. So we put another bag around the can. So again, the spacecraft is triply protected here. You see them lift that assembly in preparation to make the 1 mile or 1.5 mile drive from the payload processing facility to SLC 2. That was done on January 13th. It went very well. We got installed on the Delta II rocket. Had no issues whatsoever. We've had a very, very smooth payload processing flow here.
Can you tell us briefly what's going to happen later tonight after it comes off the rocket? When does the solar array start to deploy, and how does that solar array sequence work? We have some animation too.
We have animation. Yeah, that's fantastic. Right. Let's go ahead and roll the animation, please. So here you see the fairing payload, the payload fairing separate. That happens about 4 minutes after liftoff. We separate from the upper stage 57 minutes after liftoff, not quite an hour. Onboard sequences on the spacecraft immediately begin to establish communication with the ground via the TDRS tracking relay network. We expect to have the spacecraft immediately begin to deploy the solar arrays, and once the arrays are deployed, the spacecraft attitude control system will start looking for the sun. At that point, we're pointed on the sun. We've established communication. That process could be done as early as 8 minutes after we separate, but it could take as long as 50 minutes, depending on our orientation after separation. Now we're looking at the big reflector being deployed. That starts about 2 weeks after launch. Takes about 2 weeks to get through that. And then 50 days after launch, we'll actually spin that big antenna up, and here you see that dramatically shown in the animation. You see the spacecraft actually counter-rotating. It rotates in the reverse direction until we get spun up to full speed. And at that point, we're ready to turn on both our instruments, the Goddard radiometer and the JPL radar, and we can actually begin sending the valuable science data back to Earth for the scientists to begin the calibration and validation process.
Well, Kent, thanks so much. I know you're looking forward to the launch, but I know you're also looking forward almost as much to seeing those solar arrays start to come out
very
after
much.
We're off the rocket. So
we look forward to each step. You know, we take it one step at a time. It's fantastic to get to launch night here. We're hoping that we'll have clear skies for all the folks that are going to be watching here at Vandenberg. And the spacecraft, the rocket, will do a flyby at JPL. We hope at JPL the skies are clear enough so the folks there will be able to give it a wave off quickly as it flies by. Thank you very much, George.
Thank you, Kent. And we're now at T-minus 36 minutes, 20 seconds and counting. This is Delta Launch Control.
Closed. Vehicle lock sync vent open. Open. Prop 2 cycle lock stump open. When below 99%, then closed. Roger. Prop 1 begin cycling vehicle lock sync vent at 10-minute intervals. Roger.
T-minus 36 minutes.
Prop 2 allow locks to boil off to 95%, then maintain at 95%.
And brake Prop
Roger.
1. And could you go in silent mode for completion of locks loading and
Will do.
auto decay checks? Okay, this is the LCN countdown net 1. We're going to be proceeding.